Exponents, Unit 5, Lesson 6. We're almost to the end of Unit 5. We've got this section and one more lesson to go. So the idea behind here is that we have exponents that are considered rational, as in like they're fractions, okay? For any real number b and any positive integer n, b to the 1 over n is the nth root of b. So look at these examples right here. We have the 27 to the 1/3 is going to really mean the third root of 27. So we can reduce that by finding the third root of 27, which is 3. If we have a negative number to a 1/2 power, that's just like saying square root of -16. So in our case, we could reduce that to 4i. So we're going to practice with example 1, writing each form. So it says, part A says write x to the 1/6 in radical form. So the denominator of our fraction is going to be 6. So that's the root that we're going to take. So 6th root of x. And so now that we've introduced that radical, we are in radical form. And that's it for example, or part A. Part B says write the 4th root of z in exponential form. So since again, this denominator was our root, we now have our root, that's going to be the denominator in exponential form. So I'm going to have z to the 1/4 power. So that's how you go back and forth between radical and exponential form. On example 2, we are being asked to evaluate each expression. So we've talked about before how this negative exponent, okay, it makes our number go into the denominator. So now we have 1 over 81 to the 1/4. So I can rewrite that as 1 over the 4th root of 81. And then I need to figure out what number times itself 4 times. So number times the number times the number times the number is going to be 81. So if I were to reduce that, luckily there is a perfect 4th root of 81, and that is 3. So this is going to reduce to 1 over 3. So there's our part A. That's 216 to the 2/3. Now if you remember, this denominator represents your root. So if I were to write this in radical notation or radical form, I would take the 3rd root of 216, and there's a couple ways you could do it. You could square 216 and then take the 3rd root of that, or you could take the 3rd root of 216 and square that entire thing, which that's the way I'm going to go because 216 is already kind of a big enough number. So I'm going to find out what number to the 3rd power equals 216, and if you do that, you'll find that 6 times 6 times 6 equals 216. So this piece in here is going to become just 6. So now I have 6, but I still have to square it. So 6 times 6 is 36, and that's our answer. So this next part just talks about our rational exponents, and I did a little bit of that in that last example. And it says for any real non-zero number b and any integers x and y, with y being greater than 1, we can rewrite it in radical form just like this. So I mean, I kind of already did this example, something like this in the last one. Now, this is true except for when b is less than 0 and y is even. This means that a complex root may exist. That just means basically like that example where we had -16 to the 1/2. We took the square root of -16, which we ended up with 4i. So that's what that part means. So for example, they have 27 to the 2/3. Again, I would recommend this one since we know that the 3rd root of 27 is 3. Let's take that 3rd root first and then square it. So our solution would be 9 here. And you can do that same thinking for the square root of -16, whatever that is, to the 3rd power. So we're going to do that here in example 3. We're going to simplify each expression. We've got a to the 2/7 times a to the 4/7, and whenever you multiply these numbers, we're going to add the exponents. So this will now become a to the 6/7. And that's all we really need to do for that. There's not much we can do after that. If it said to write it in radical form, which it doesn't, so we're good with this. But in radical form, we would have the 7th root of a to the 6th. Okay, let's look at part B here. We have a negative exponent, so automatically we're going to move this to the denominator and make that 5/6 positive. Okay, now the issue is we have a fraction, a rational exponent. We have a fraction in the denominator, and we don't want that. That's just like having that radical, because if we were to write it in radical notation, we would have the radical in the denominator, and we said that was against the law. So we're going to fix this by multiplying by something that would make this fraction disappear. So if I took b to the 1/6 and multiplied it to the numerator and denominator, I would get b to the 1/6 on the top over, now this is going to end up being 5/6 plus 1/6, which is 6/6, which is just 1. So b to the 1st power on the bottom. Okay. Example 4 says to simplify each expression. So right here we have the 4th root of 27 over the square root of 3. Now, the issue is the 4th root of 27 is not a glorious number. So what I'm going to do, I'm going to first rewrite this. 27, this is 27 to the 1/4 power. This is 3 to the 1/2 power. What would be nice is if we had the same base, and then we can simplify the exponents, or we can combine the exponents that way. So we're trying to get 27 to the same base as 3. Well, 27 equals 3 to the 3rd. So what I'm going to do is I'm going to replace 27 with 3 to the 3rd. So this right here is now going to be 3 to the 3rd to the 1/4. I don't know why I'm writing it that way. To the 1/4 over 3 to the 1/2. So this will become 3 to the 3/4 over 3. Can I just change this to 2/4 so we can see the same thing? What happens to exponents when we're dividing these numbers is we're going to subtract them. So we have 3 to the 3/4 over 3 to the 2/4. We're going to subtract 3/4 minus 2/4 equals 1/4. So this simplified is 3 to the 1/4. And then you could also write this in radical form, 4th root of 3. This next one we have the 3rd root of 64z to the 6th. So we're trying to figure out, well, first of all, we need to distribute this 3rd root. So we want 64 to the 1/3 power, z to the 6th to the 1/3 power. We need to figure out what number times itself 3 times is going to be 64. And that's going to be 4. 4 times 4 times 4. So that reduces to 4. Here we have a power to a power. So when we multiply this, this would be z to the 6/3, which z to the 6/3 is going to be 2. 6 over 2. 6 over 3 is 2. So this will be z squared. So your simplified answer there is 4z squared. Sorry, my words aren't fully coming together tonight, but hopefully this makes sense. I am going to do a homework help video for you guys on our website, so stay tuned for that. Let me know if you guys have questions.